Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Hello everyone. I'm glad to see you here. To start our conversation, could you explain the foundational concepts behind language models and how their focus has shifted over time towards enhancing reasoning and problem-solving capabilities?
Language models are like very smart robots that learn to understand and create text by reading lots and lots of information, just like a child learns to speak and write by listening to adults and reading books. Over time, these language models have evolved from simply repeating back what they have learned to being able to think more deeply and solve tricky problems. In the past, models focused mainly on understanding language and producing fast responses. But now, with the introduction of the OpenAI model, there's a big shift. Think of the OpenAI model as a student who takes their time to think through a tough math problem instead of rushing to write down an answer. This model has been designed to pause and mull over complex tasks, much like a person might pause to think before answering a hard question. This new approach is called reasoning, which is like having a mental toolbox where the model can pick different tools, or ways, to solve a problem. It learns to recognize when it makes a mistake, breaks big challenges into smaller, manageable steps, and tries different methods if one way isn't working. Overall, the language models have become more like thoughtful problem solvers, focusing on giving better and more logical answers rather than just being fast, which is a significant advancement in their capabilities.
That's a fascinating overview. Could you elaborate on how the OpenAI model specifically enhances its reasoning capabilities compared to previous models? What techniques or methodologies does it employ to improve its performance on complex tasks?
The OpenAI model enhances its reasoning capabilities by using a thoughtful approach that allows it to tackle complex tasks more effectively than previous models. Imagine a student who not only studies hard, but also learns how to think critically about problems. This model is trained with reinforcement learning, which is like a coach helping an athlete improve by giving feedback and guiding them through practice. One key technique it uses is generating reasoning tokens, which are like notes a student might jot down while thinking through a problem. These tokens help the model to consider various methods and strategies before arriving at a final answer. After generating these thoughts, the model produces the visible answer and then discards the reasoning tokens, keeping the focus clear and on the essential information. Additionally, OpenAI has shown remarkable performance on challenging benchmarks, even surpassing experts in specific fields like chemistry, physics, and biology. This indicates that it's not just memorizing facts, but also applying deeper thinking to solve problems effectively. By breaking down tricky questions into simpler parts and trying different approaches when stuck, the OpenAI model acts more like a careful problem solver rather than just a fast answer machine.
That's an intriguing explanation. Can you discuss the implications of OpenAI's ability to outperform experts in fields like chemistry, physics, and biology? How might this affect real-world applications, such as coding assistance or scientific research? And what are the potential benefits and challenges of integrating this model into those areas?
The OpenAI model's ability to outperform experts in fields like chemistry, physics, and biology carries significant implications for real-world applications, especially in areas such as coding assistance and scientific research. Think of it like having a very knowledgeable helper who can assist with difficult tasks that typically require years of study. In coding, for example, the OpenAI model can become a powerful tool for developers, helping them write code more efficiently and accurate. It can plan, think, and execute tasks almost as if it were a skilled programmer. This means that even those with less experience in coding can create complex programs with the model's assistance, much like a novice artist being guided by a master. For scientific research, OpenAI's proficiency at solving challenging problems could accelerate discoveries and enhance understanding in various fields. Researchers might use it to analyze data, generate hypotheses, or even simulate experiments. leading to faster advancements in knowledge and technology. However, there are challenges as well. While AI may excel in specific tasks, it doesn't mean it replaces human expertise entirely. Human oversight is crucial, especially in interpreting results and making ethical decisions. Additionally, integrating such advanced models requires careful consideration of how they are used to ensure accuracy and prevent misuse. Overall, the potential benefits of using AI in these areas are immense, but they come with the responsibility to use this powerful tool wisely and thoughtfully.
That's a compelling perspective on the balance between the capabilities of the AI model and the need for human oversight. Could you delve deeper into how the model addresses potential ethical concerns and ensures accuracy in its applications, particularly in sensitive domains like healthcare or legal systems? What safeguards or mechanisms might be put in place to manage these issues effectively?
The AI model's capabilities in sensitive areas like healthcare or legal systems raise important ethical concerns, particularly regarding accuracy and trustworthiness. Since these fields often involve critical decisions that affect people's lives, it's essential to have safeguards in place to ensure that the model's applications are responsible and reliable. One method to address these concerns is through rigorous testing and validation. For example, the AI model has already been evaluated against human experts in challenging benchmarks, showcasing its proficiency. This type of evaluation helps build confidence in its capabilities, but it also highlights the need for continuous oversight by qualified professionals. Moreover, integrating the model into sensitive applications could involve implementing mechanisms for human-in-the-loop supervision. This means that while the model can assist with generating insights or solutions, human experts would review and confirm the final decisions or action. This partnership ensures that critical thinking, ethics, and contextual understanding are maintained. Additionally, transparency in how the model operates can also play a vital role. By making it clear how the model reaches its conclusions, users can better understand its decisions and identify potential errors or biases. In summary, while the AI model shows great promise in solving complex problems, especially in sensitive domains, it is crucial to pair its capabilities with human oversight, rigorous testing, and transparency to manage ethical concerns effectively and ensure accuracy in its application.
Thank you for that thorough explanation. Could you also discuss the potential limitations of the AI model? In what scenarios might it struggle? And how does its emphasis on reasoning and problem-solving impact its performance, compared to models that prioritize speed and output?
The AI model, while advanced in reasoning and problem-solving, does have its limitations. One of the main areas where it might struggle is in scenarios that require very rapid responses, or where speed is critical, such as real-time decision-making in emergency situation. Since the AI model takes time to ponder and analyze, it may not be the best choice when immediate action is necessary. Additionally, in situations involving tasks that require a wide array of factual knowledge, such as trivia or tasks heavily reliant on memorization, AI may not perform as well as models designed specifically for fast retrieval of information. This difference arises because AI emphasizes deeper reasoning rather than quick responses, which can lead to slower performance in those contexts. Moreover, well as models designed specifically for fast retrieval of information, AI might face challenges when dealing with ambiguous or poorly defined problems, where clear reasoning paths are hard to establish. If the problem isn't well structured, the model could struggle to generate a logical response, as its reasoning process relies on clear steps and defined information. Overall, while AI's focus on reasoning enhances its ability to tackle complex tasks thoughtfully, this emphasis can sometimes lead to slower performance compared to models that prioritize speed and straightforward output. Therefore, the choice of model should depend on the specific requirements of the task at hand, balancing the need for reasoning with the necessity for quick responses.
That's a valuable insight into the limitations of the OON model. Considering these challenges, how do you envision the future of language models evolving? What advancements or innovations could be explored to enhance the strengths of models like OON while addressing their current limitations, particularly in terms of speed and efficiency?
The future of language models like OON could evolve significantly as advancements are made to enhance their strengths while addressing current limitations. Here are some potential innovations that could be explored. 1. Hybrid models. 1. Combining the reasoning strengths of one with the speed of other models could create a hybrid approach. Imagine a model that can quickly retrieve factual information while also applying deep reasoning when necessary. This would provide the best of both worlds, allowing for fast responses without sacrificing the quality of answers. 2. Optimized processing. Innovations in how models process information could improve efficiency. Techniques like more effective token generation and management could reduce the time taken for reasoning. For instance, if the model could prioritize certain types of reasoning based on context, it might be able to address questions more swiftly without losing depth. 3. Contextual memory. Implementing a form of contextual memory could help the model remember relevant information from prior interaction, enabling it to respond more quickly in ongoing conversations. Like how we remember previous discussions to inform our current thoughts, this capability could enhance efficiency. 4. Modular learning. Developing modular components that specialize in different types of tasks, like math, coding, or scientific reasoning, could allow the model to switch gears more rapidly based on the task at hand. Each module could be fine-tuned for speed in its specific area while maintaining the depth of reasoning. 5. User adaptation. Allowing the model to adapt to individual user preferences could streamline interaction. By learning how different users prefer to ask questions or what types of answers they value, the model could tailor its responses to be more efficient and relevant. These advancements could make models like OON more versatile, reducing the trade-off between speed and the depth of reasoning. As technology progresses, the aim would be to create models that can think deeply, respond quickly, and adapt to the specific needs of users, thereby providing even more value in various applications.
Those are intriguing possibilities for the future of language models. As we look ahead, how might the integration of these advancements impact user experience and the overall landscape of AI applications? Could you explore the potential benefits for different user groups, such as researchers, developers, and everyday users?
The integration of advancements in models like OON has the potential to significantly enhance user experience and transform the landscape of AI applications across different user groups. 1. Researchers. For researchers, the OON model can serve as a powerful assistant in complex problem-solving scenarios. Its ability to reason through challenging tasks means researchers can leverage it to generate hypotheses, analyze data, and even draft studies. This could lead to quicker advancements in various fields like science and technology, enabling researchers to focus more on interpretation and less on the computational heavy lifting. 2. Developers. Developers stand to benefit immensely from the integration of OON into coding assistance. Its reasoning capabilities allow it to help write more efficient code, debug issues, and even suggest optimizations. This could lead to a surge in productivity, particularly for those who may not have extensive programming experience. The excitement around code generation tools powered by OON hints at a new era of rapid application development, where developers can create more robust applications in less time. 3. Everyday users. For everyday users, the enhancements in language models can improve interactions in applications like virtual assistants or customer service bots. With more refined reasoning skills, these models can provide more accurate and contextually relevant responses, making for a smoother user experience. This could lead to increased trust in AI systems, encouraging more widespread adoption in daily tasks, from scheduling to information retrieval. Overall, as these advancements unfold, we could see a more collaborative environment where AI works alongside humans, helping various user groups to achieve more than they could independently. This evolution has the potential to create applications that are not only more efficient, but also more intuitive and user-friendly, ultimately changing how we interact with technology.
Thank you for sharing such a comprehensive view. As these advancements materialize, what ethical considerations should be prioritized to ensure that the integration of enhanced language models like UN remains responsible and beneficial for society as a whole? How can stakeholders, including developers, researchers, and policymakers, collaborate to address these concerns?
As advancements like the UN model become integrated into society, several ethical considerations should be prioritized to ensure that their deployment remains responsible and beneficial. Here are some key areas of focus. 1. Transparency and accountability. It is essential for developers and organizations to be transparent about how these models work and the data they are trained on. Clear communication about the model's capabilities and limitations can help users make informed decisions. Establishing accountability for the outputs generated by these models is also critical, particularly in sensitive fields like healthcare and law. 2. Bias and fairness. Language models can inadvertently reinforce biases present in their training data. Stakeholders should prioritize efforts to identify and reduce biases in model outputs. 3. This could involve regular auditing of model performance across diverse demographic groups and implementing strategies to ensure fairness in applications. 3. User education. Educating users about the capabilities and limitations of models like UN can empower them to use these tools effectively and responsibly. This includes informing users about the importance of human oversight, especially in high-stakes scenarios. 4. Data privacy. Protecting user data is paramount. Developers must ensure that any data used in training or interactions with models respects user privacy and complies with relevant regulations. This involves implementing data protection measures and being transparent about data usage. To address these ethical concerns, collaboration among various stakeholders is essential. Developers can work together to establish best practices for model training, evaluation, and deployment that consider ethical implications. Researchers can contribute by studying the impacts of these models on different populations and developing methodologies to mitigate bias and improve fairness. Policymakers play a vital role in creating regulations and guidelines that govern the use of AI technologies, ensuring that ethical considerations are embedded in the development and deployment processes. By fostering collaboration and establishing robust ethical frameworks, stakeholders can help ensure that the integration of advanced language models like UN remains beneficial for society, promoting positive outcomes while minimizing potential harm.
That's a well-rounded perspective on the ethical implications of advanced language models. As we move forward, how can ongoing research and development in AI contribute to continuously improving these models, particularly in terms of enhancing their reasoning capabilities while maintaining ethical standards? What role do you see for interdisciplinary collaboration in this process?
Ongoing research and development in AI will play a crucial role in continuously improving models like UN, especially in enhancing their reasoning capabilities while upholding ethical standards. Here are ways in which this can unfold. 1. Refine training techniques. Research can focus on developing training methods that prioritize reasoning over simple output generation. For instance, reinforcement learning techniques can be further refined to ensure that models not only consider various approaches in problem solving, but also learn from their mistakes effectively. This would lead to models that can think critically and adaptively. Tanderbel, Conway, World, Ukikagort, Baringao. Benchmarking and evaluation. Establishing comprehensive benchmarking systems that assess not just accuracy but also ethical considerations can guide the development of more responsible AI models. Continuous evaluation against diverse datasets will help identify biases and areas for improvement, ensuring models are fair and reliable. 3. RAI, user-centric design. Research into user interaction with AI models can inform design choices that enhance user experience. Understanding how different user groups interact with models can lead to insights on how to make reasoning processes more intuitive and accessible while maintaining ethical considerations. Interdisciplinary collaboration will be vital in these efforts. AI researchers and ethicists. Collaborating with ethicists allows for a better understanding of the societal implications of AI technologies. By integrating ethical considerations into the research and development process from the start, potential harms can be mitigated. Developers and policymakers. Collaboration between developers and policymakers can help ensure that the frameworks governing AI use are up to date and relevant. This can facilitate the establishment of guidelines that promote ethical standards, while also allowing for innovation. Academics and industry practitioners. Bringing together academic researchers and industry practitioners can foster knowledge exchange that enhances both theoretical understanding and practical applications, ensuring that advancements in reasoning capabilities are aligned with real-world needs. By prioritizing these areas and encouraging interdisciplinary collaboration, the ongoing evolution of language models can lead to systems that are not only more capable in reasoning, but also aligned with ethical standards, ultimately benefiting society as a whole.
Thank you for such an insightful discussion. To wrap things up, could you summarize the key takeaways regarding the significance of the UN model and its potential impact on the future of AI applications, emphasizing its ethical considerations and collaborative efforts?
The introduction of the UN model marks a significant advancement in AI capabilities, particularly in its reasoning processes. Here are the key takeaways regarding its significance and potential impact. 1. Enhanced reasoning capabilities. The UN model's ability to perform complex reasoning allows it to analyze problems more deeply, similar to how humans think through difficult questions. It can recognize and learn from its mistakes, break down challenges into simpler steps, and explore multiple approaches before generating a final response. This makes it particularly effective for tasks that require logical thinking, such as math, coding, and scientific inquiries. 2. Ethical considerations. As the capabilities of models like UN expand, it is crucial to prioritize ethical standards. This includes addressing issues of bias, ensuring transparency in how models operate, and protecting user data by striking a balance between advanced functionality and ethical considerations will be essential to foster trust and reliability in AI application. 3. Collaborative efforts. The ongoing development and refinement of UN will benefit from interdisciplinary collaboration. Developers, researchers, ethicists, and policymakers can work together to enhance the model's reasoning capabilities while ensuring that its deployment adheres to ethical guidelines. This collaboration can help guide responsible AI practices, leading to systems that are both powerful and trustworthy. 4. Impact on AI applications. The UN model's integration into various applications, such as coding assistance, stands to transform how individuals and organizations approach problem solving. By providing better and more logical answers, it can significantly improve productivity and innovation across different fields. In conclusion, the UN model represents a critical step forward in AI, combining enhanced reasoning with a commitment to ethical standards. Through collaborative efforts, stakeholders can ensure that the advancements in AI contribute positively to society, fostering innovation while safeguarding ethical integrity.
Thank you for joining us today. We've explored how language models, like OWN, enhance reasoning and problem-solving through techniques like generating reasoning tokens. This thoughtful approach improves answer quality, but may impact speed. As these models become more capable, ethical considerations such as bias and accountability become paramount. Ongoing advancements include hybrid models, optimized processing, and user adaptation to enhance efficiency. Interdisciplinary collaboration among developers, researchers, and policymakers is crucial for responsible integration, balancing ethical standards with innovation. OWN's enhanced reasoning capabilities, need for responsible development, and potential to transform AI applications are significant. Thank you for your attention.